Hey guys, great to be back with you all again today. We're going to be talking about problem solving. The specific skill we're going to talk about today is 3.5a, represent one and two-step problems involving addition and subtraction of whole numbers to 1000 using pictorial models, number lines, and equations. And the I can statement is, I can use different models to solve addition and subtraction problems. Go ahead and look at our vocabulary a little bit here. For addition, we have addend plus addend equals the sum. So the sum is the answer to an addition problem. And subtraction, difference is the answer to a subtraction problem. So sum for addition, difference for subtraction. We've got a couple videos, or a few videos. One of the videos is going to be a STAAR test question from 2016. It's question number 28, and it's over the skill that we're talking about today. Then I'm going to do a video of me using models to do addition, and another one me using models to do subtraction. So let's get ready and watch the videos.
Subtraction problems. This is standard 3.5a in the great state of Texas. We're using number 28 of the 2016 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, and then unpause it. We will look at our answers together. So this is definitely a strange looking problem. We've got some number lines here, and we have basic addition and subtraction problem, but most of us are not used to representing that on number lines. So let's see if we can figure this out together. So there were 25 people in the library. Some left, some people went away, and now there's 13 people left. But how do we represent that? Well, let's see what we have. We've got 25 people. Some went away. We don't know how many that is. And that leaves us with 13. Well, there's a few different ways we can solve this. One way would be to actually see if we can figure out what that missing number is. There's a few different ways we can do that. So let me just put 25 here. And I know that 5 times 5 makes 25. So what I'm going to do is I'm just going to make a little block of 5 by 5, and that's going to represent my 25 people. So if there are only 13 left, this is what I'm going to do. I'm going to put a box here around these 13. These are the people that are still here. And so I'll say they remain. So whoever's left is going to tell me these are the people that went away. Went away. So it looks like I've got 5, 10, 12. So I can double check that. I can make sure I did that correct. 25 minus 12. Let's see, that's going to be no grouping needed. That is going to be 13, so that works. So 12 people went away, but obviously that's not what we're looking for, but that is going to help. Another way I could have solved this is I could have said, well, 13 plus something equals 25, because I could use inverse operation. I can use a fact family, and then maybe I could have counted up from 13 up to 25. But either way, we know our answer is 12. So let's look at our answer selections, F, G, H, and J. So all of them start right here. Well, actually not G. F and J both start at 25, so that's good. G and H don't, so we're going to look at F and J first. So on F here we have 25, and then it looks like that goes up to, that's 38. So what they do is they have 25, and then you see how the arrow goes to the right. That means we're going to add this 13, which gives us a total of 38. And the problem is we're looking for the number of people who left the library. 38 people did not leave the library because only 25 people were in there to begin with. They just took the two numbers and added 25 and 13. And obviously that is not what we did. So let's take a look at J. So J starts with 25, and you see the arrow moves from 0 up to 25. So that lets you know how many you're starting with. But then it kind of doubles back on itself and it moves back this way. Look at this arrow. It's going back to the left, and it goes back to left, and it ends at 13, which is how many people were left. And so what we could do is we can figure out, well, how many people left the library? Well, you can count to see how many ticks this line is, and it's going to be 12. And so this looks like it's going to represent 25 minus 12 to get you to 13. So I'm thinking this is it. Let's see about G. G starts just at 13, and then they add 12, I think that's 12, to get up to 25. So when you get up to 12 to get up to 25, well, that could work, but it doesn't represent this number sense, because what we need to do is we need to start all the way up at 25 and then move back. So that's actually pretty close, but that's not going to show what we need here. And then finally, H just doesn't look like they finished. They just went up to 13 and stopped. At least G tried to add that 12 to get back up. So our answer is going to be J.
Okay, we're going to do some addition problem here. We're going to do 388 plus 433, and we're going to do it 3 different ways. I'm going to use a base 10 blocks, which is the more concrete way of adding. I'm going to do the pictorial model, which is a little bit more abstract. And then the most abstract way, which is the way that we want third graders to do it by the end of the year, or as soon as possible, really, is the most abstract way of doing it. It's kind of the standard, we call it standard algorithm way of adding 3-digit numbers by 3-digit numbers. So I'm going to start with the more concrete way. I'm going to start with the base 10 blocks, and I always like to start in the ones place. That way, if I have to regroup, it makes a little bit more sense. So in the ones place, I have an 8 and 3, so that'd be 8, 9, 10, 11. But I can't have 2 digits in the ones place, so I'm going to regroup. I'm going to move these up just a little bit right here. Actually, I'm going to move them all together right here. And I'm going to switch it out with a 10. That way I don't have 2 digits in the ones place. So I'm going to take that 10 right there, and I'm going to move it over to the tens place. So now I have 1 left in the ones place. So over here, same thing. I've got 8, 9, 10, 11. Okay, but I can't have 2 digits in the ones place. So I'm going to regroup. I'm going to take 10 of them. I'm going to move them over to the tens place, and I'm going to add another 10 to the tens place. Okay, and on the standard way of doing it, 8 plus 3 is 11, but I cannot have 11 in the ones place. So I'm going to put the 1 from the 11 in the ones place, and I'm going to regroup and put another 10 in the tens place. So I did it. I'm going through step by step. I did it in the concrete, abstract, and the most abstract way of doing it. Okay, I'm going to go to the tens place now. I'm in the tens place, and I've got 8, 3, and 1, or 80, 30, and 10 right there. And when I add that together, I got 8, 9, 10, 11, 12, or 120 right there. And I can't have 120 in the tens place. I only want 10 in the tens place. So I'm going to regroup again. So I'm going to take 10 of them, put them together here. That's 8, 9, and 10. And that's the same as 100. I'm going to take that. I'm going to regroup over the hundreds place right there. And now I have 2 tens. Okay, with the pictorial model, same thing. I have an 8 or 80, 90, 100, 110, 120. So but I can't have 120 in the tens place. There's 100 there. So I'm going to go ahead. I'm going to regroup. I'm going to take 10, which will be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. I'm going to move that over to the hundredths place. And on the standard way of doing it, same way. I've got 8, 9, 10, 11, 12. I'm going to go ahead and put the 2 from the 12 right there. I'm going to regroup the 100 over the hundreds place, which is actually 120 and it's not 12. So now I'm going to go back over to my base 10 blocks. I'm going to go ahead and count up how many hundreds I have. I've got 1, 2, 3, 4, 5, 6, 7, 8 hundreds. I have 8 hundreds. Put them all together here. That's 800. And on my pictorial model, 1, 2, 3, 4, 5, 6, 7, 8. That's 800. Okay, and in the standard algorithm, 4 plus 3 plus 1 is 8, which is 800. So when we compare all these, okay, starting with the, let me go back here and circle these. Base 10 blocks, I have 821. Pictorial model, I have 820 and 1. And the standard way of doing it, or standard algorithm, is 821. So that just shows you 3 different ways to do a 3-digit by 3-digit addition problem. And okay, we're going to do a subtraction problem right here. You're going to use base 10 blocks, pictorial model, and the standard way of subtracting. And you see over here, I'm using grid paper because I think that's absolutely the best way to do any computation is use the grid paper that they give you to do the problems. And it really helps you line up your place value really good. And the problem we're going to do is 456 minus 268. And you can see I modeled the top number over here with the base 10 blocks. This is 456. This is the pictorial model, that's 456. And this is a standard way of how we write it out. So I'm going to start in the with the base 10 blocks. And it's telling me to take, I always like to start in the ones place because it makes it easier to regroup to me. So it's asking me to take 8 away from 6. And you see I cannot take 8 away from 6 because there's only 6 of them. So that means I have to regroup. So I'm going to take one of my 10s and I'm going to move it, basically move it over to the ones place. So now I have 10, 11, 12, 13, 14, 15, 16 ones. And now I can take 8 away from it. So if I take 8 away, that would be right there, 8 of those. And now we have 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 ones now. On the pictorial model, I'm going to do the same thing. I'm going to try to take 8 away, but only have 6, so that means I'm going to have to regroup. I'm going to take one of my 10s, and I'm going to move it over here. I'm going to move it down here. And that's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, now I can take 8 away from that. That would be 1, 2, 3, 4, 5, 6, 7, 8. And that looks like it leaves 8. One, 2, 3, 4, 5, 6, 7, and 8. So I have 8. And in the standard algorithm, I cannot take 8 away from 6. So that means I need to regroup. I'm going to take one of my 10s. That's going to leave me 4 10s. And that's going to give me 16 ones. Now I can take 8 from 16. I know 8 from 16 is 8 because 8 plus 8 is 16. And there you go. You see in all the different ways of doing it, I got 8, 8, and 8. Okay, now I'm going to go to the tens place on my base 10. Okay, I have 4 left, and it's telling me to take 6 away. So that means I have to regroup again. So I'm going to take one of my hundreds. I'm going to replace it with 10 tens, which is 100. Now in that place value, I have 3 over here. It looks like I have 14 here because that's 10 and 4 is 14. Now I can take 6 away from that. That's all but 4 up here. So take away 6. That looks like it leaves 4 and 4, which is 8. So I have 8 or 80 in the tens place now. Same thing on my pictorial model. Okay, on my pictorial model right there. Okay, it's telling me to take 6 away, but I only have 1, 2, 3, 4. So that means I'm going to have to regroup from the hundreds place. I'm going to take one of my hundreds. So take this one down here and move it over here. That's going to be 10 tens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I can take 6 away, which would be that entire line and one of these. And that leaves 1, 2, 3, 4, 5, 6, 7, 8. So that leaves 80. And same thing on my standard algorithm. I cannot take 6 away from 4, so I'm going to go to the hundreds place. I'm going to take one of my hundreds, that's going to leave 3 hundreds. And I can make that into 14 tens or 140. And 6 from 14 would be 6, 7, 8, 9, 10, 11, 12, 13, 14 is 8. So 14 minus 6 is 8. And in my last place value, my hundreds place value, it's asking me to take 2 away from 3. That looks like that leaves 100. Same thing right here. Take 2 away from 3. 1, 2. That leaves 100. And right here on my standard algorithm, 2 minus 3 equals 100. So you can see on all 3 models, I have 188, 188, and 188. And that just shows you 3 different ways. Use a base 10 blocks, pictorial models, and the standard way to do subtraction with regrouping. Okay, let's go and look at this guided practice problem. It says Nikita jogged 12 miles last month. Gabrielle jogged 2 more miles than Nikita. Which equation can be used to find the number of miles that Nikita and Gabriella jogged combined? So I'm going to circle some important information on this one. It's important that Nikita jogged 12 miles. Gabriella jogged 2 more miles than Nikita. And that's really all the information that we really need to solve the problem. And then I would underline the question, which equation can be used to find the number of miles that Nikita and Gabrielle jogged combined? So I'm going to box in some operational clues. I see the word combined right there. And 2 more miles. Okay, right there. Okay, so I'm looking at this information, and I'm going to do some evaluating right now. I think the thing that I would use, or the problem-solving strategy that I'd use, would be make a table. So I'm just going to make a table with how many miles Nikita jogged and how many miles that Gabriella jogged. So I know Nikita jogged 12 miles, and it says that Gabriella jogged 2 more miles than Nikita, so that would have been 14 miles. So if I want to find out how many miles they jogged combined, I would have to add those 2 together. So I would do 12 plus 14. So what is 12 plus 14? Yeah, that's correct. It would be 26. So combined, they jogged 26 miles. So we'll just go through here and figure out which equation equals 26 miles. So answer choice A. What does that answer choice A equal? Yep, if you add that up, 12 plus 12 is 24, plus 2 more would be 26. So that looks like that may be the one we want. Let's look at answer choice B. What's 12 plus 2? Yep, 12 plus 2 is 14, and that does not match our 26 miles. Answer choice C. What is 12 plus 12 minus 2? Yeah, I know 12 plus 12 is 24. You take 2 away from that, that would be 22. That does not match what we came up with. And answer choice D. What is 12 minus 2? Yep, 12 minus 2 would be 10. That one does not match either. So the equation that we would use is 12 plus 12 plus 2 to figure out how many miles they jog combined. Answer choice A. Okay, let's look at this next guided practice problem. It says Chase has 16 baseball cards. He will buy 8 more cards on Tuesday and 12 more cards on Wednesday. Which model represents the total number of cards Chase will have? So I'm going to circle some important information. Looks like he started with 16 baseball cards. And he buys 8 more cards. And on Tuesday and Wednesday, he gets 12 more cards. Okay. So, underline the question. The question is, which model represents the total number of cards Chase will have? Box some operational clues right here. Okay, and the question's asking the total. Okay, so that means we don't know what the total is. So I'm pretty sure, that's kind of leads me down a road of what operations we're going to use. And he bought. I see somewhere in here it says he bought, or he will buy. Okay, when you buy something, you get more of it. So these sound like an addition sentence. Okay, if he started with 16, and then he buys 8 more on Tuesday, and then Wednesday he gets 12 more. That looks like the equation that we would use to solve the problem. So let me look at the answer choices. Answer choice F. Answer choice F looks like it's started 16. That's what we started with. He made a jump here and he made a jump there. So that looks like that that could be one of our answers. So I'll put an M right there. Okay, this one right here looks like we jump to 16, start with 16, then make a jump here, and then we go back here. Okay, so whenever I go back on the number line, that sounds like it's subtraction. So I could probably eliminate answer choice G. Answer choice H. I make a jump right here to 16. That's where I'm starting at. I make another jump and another jump. I make 2 jumps to the right. So that sounds like I'm adding 3 numbers together there also. So I can put an M right there too. And J. This one's got one big jump to 36. We jump back once and we jump back again. So that sounds like it's a subtraction problem also. So I can eliminate that one. So we got 2 maybes there. Okay. And I'm looking at where they end at. Okay, this one ends on 40 and this one ends at 36. So let's just go ahead and solve this right here to figure out how many cards he would have. And then whichever number line he ends on, it ends on that number that will be the correct one. It's either going to be 36 or 40 cards. So what is 16 plus 8 plus 12? Okay, we'll work it out. I like to stack numbers up when I add them. So I got using my place value. And then I got all my numbers together by place value. I know 8 plus 2 is 10, plus 6 more would be 16. And then I regroup one more over here. Then I have 3 10s, which is 30. So that means he's got 36 cards here. So that means answer choice H would be my correct answer. Okay, it's time to complete your independent practice. There will be a blue puzzle piece at the very end. That's the last thing in the folder there. But I'll put in a PDF in there for you to print out. Typically, you do better when you print out the worksheets and work them out on pencil and paper. It gives you a place to work them out and a place to use your cube strategy. And but just take your time, do your very best. If you have any questions about anything or something doesn't seem like it's working like you think it should, please send your teacher a message, either an email or send them a message in Schoology, and they'll get back to you really quick. And best of luck to you. We'll talk to you later.